Donald Knuth, the literal father of computer science, the man who wrote The Art of Computer Programming, the reason we have algorithm analysis, just published a paper. It's titled Claude's Cycles, as in Claude, the AI, because Claude Opus 4.6 solved an open problem in graph theory that Knuth himself had been stuck on for weeks. The man who invented TeX, who has been writing the definitive textbook on algorithms for 60 years, just admitted that an AI outpaced him. And then he named the paper after it. This is not a drill. So here's the full story. Donald Knuth, who is 88 years old and still actively publishing research at Stanford, was working on a conjecture about Hamiltonian cycles in directed graphs. If you're not a math person, a Hamiltonian cycle is a path through a graph that visits every single node exactly once and returns to where it started. Finding these cycles in directed graphs, where the edges only go one way, is one of the hardest problems in combinatorics. It's NP-complete in the general case. Knuth had been grinding on a specific open conjecture for weeks, trying different approaches, running into dead ends. This is a guy who has spent his entire career solving problems like this. He doesn't get stuck easily, but he was stuck. So he decided to try something. He gave the problem to Claude Opus 4.6. Not as a simple prompt, he engaged in what he describes as a systematic exploration. Claude worked through 31 different approaches over about an hour, and on one of those explorations, Claude found the key insight that cracked the conjecture. Knuth didn't just copy-paste Claude's output. He took that insight, verified it rigorously, and wrote the formal mathematical proof himself. But the breakthrough, the thing that unlocked the problem, came from Claude. And Knuth was honest enough to say so publicly. Let me explain why this matters more than you might think. There are a lot of stories about AI beating humans at various tasks. AI beats chess grandmasters. AI beats Go champions. AI writes code. We've gotten kind of numb to it. But this is different for 3 reasons. First, this is Donald Knuth. This is not some random researcher. This is arguably the most important computer scientist alive. When Knuth says something about computing, the entire field listens. He's been skeptical of generative AI. He's on record questioning whether large language models truly understand anything. And now, he's publishing a paper where the title credits an AI for the key contribution. Second, this wasn't a benchmark or a competition. This was real, unsolved mathematics, an open conjecture that didn't have a known answer. Claude didn't just pattern match against existing solutions, it had to reason about a genuinely novel problem and find an approach that didn't exist in its training data. Third, look at what Knuth said afterward, and I want to quote this exactly. "It seems that I'll have to revise my opinions about generative AI one of these days." Coming from Knuth, that is seismic. This is a man who chooses his words with extreme precision. He's not saying AI is sentient or that mathematicians are obsolete. He's saying his mental model of what these systems can do was wrong. And if Knuth's mental model was wrong, how confident should the rest of us be in ours? Let's get into the technical details because they're fascinating. The paper is available on Stanford's CS faculty page, and it describes exactly how the human-AI collaboration worked. Knuth didn't just paste the conjecture into a chat window and say, "Solve this." He set up a structured exploration. He would pose specific subproblems to Claude, evaluate the responses, redirect when Claude went down unproductive paths, and build on the productive ones. Over 31 explorations, they narrowed down the approach. What's remarkable is the kind of reasoning Claude demonstrated. Graph theory proofs require you to hold complex structures in your head, nodes, edges, paths, constraints, and reason about their properties simultaneously. It's spatial, it's logical, and it's deeply abstract. The fact that a language model could contribute meaningfully to this kind of reasoning challenges a lot of assumptions about what transformers can and can't do. Some people on Hacker News argued that Claude just got lucky, that if you throw enough attempts at a problem, eventually you'll stumble on something useful. But 31 explorations is not a lot. A human mathematician might try hundreds of approaches over weeks. Claude found a productive direction in about an hour. That's not luck. That's, at minimum, a very effective search through the space of possible approaches. The paper also reveals something subtle about how to use AI for research. Knuth didn't treat Claude as an oracle that gives you the answer. He treated it as a collaborator that could suggest approaches faster than he could generate them himself. The formal verification, the proof structure, the mathematical rigor, that was all Knuth. But the creative spark, the "what if we try this" moment, that came from Claude. Not everyone is impressed, and the criticisms are worth taking seriously. The main argument is that Knuth Knuth was stuck on one specific conjecture, not that the problem was beyond human capability. Other mathematicians might have solved it. Maybe Knuth was just approaching it from the wrong angle, and Claude happened to suggest the right one. That's a valid point, but it doesn't diminish the fact that Claude suggested something productive in a domain where most approaches fail. Another criticism is that we're reading too much into one anecdote. AI-assisted math is still in its early days. The Fields Medal isn't going to an LLM anytime soon. True, but the trajectory matters. 2 years ago, no one would have predicted that a language model could contribute to an open problem in combinatorics. If this is what's possible now, what happens in 2 more years? There's also the question of what solved really means. Claude didn't produce a formal proof. It produced an insight that Knuth then formalized. Is that solving the problem? I'd argue it's the most important part of solving the problem, the creative leap. But reasonable people disagree. We're watching the relationship between humans and AI shift in real time. A year ago, the conversation was, AI can code, but it can't do real research. Now, we have the godfather of computer science naming a paper after an AI that helped him do research he couldn't do alone. This doesn't mean mathematicians are obsolete. It means the most productive mathematicians of the next decade might be the ones who learn to collaborate with AI the way Knuth did, using it as a tool to accelerate their own thinking, not as a replacement for it. And it means that the ceiling of what AI can contribute to is higher than most people assumed. If Claude can help crack open problems in graph theory today, what happens when the next generation of models is 10 times more capable? The problems that are beyond AI today might not be beyond AI tomorrow. Knuth understood this. That's why he named the paper Claude's Cycles, not My Proof Assisted by AI. He gave credit where it was due, and that intellectual honesty from the most respected computer scientist alive tells you everything you need to know about where we are. Donald Knuth, the father of computer science, just published a paper called Claude's Cycles because an AI solved a problem he couldn't. If that doesn't make you rethink what these systems are capable of, I don't know what will. If you found this breakdown useful, hit subscribe. See you in the next one.